So guys, as I promised, I am back again with another congruence criterion. Do you remember which one are we going to study today? Yes, it is the ASA criterion. But before learning anything about it, let's first see what Jack and Jill are up to.
Jill, I wonder how far that boat is from the shore.
You know, there is a way by which you can find the distance with the help of congruent triangles.
Really? How?
Well, it's quite simple. Pick up some sticks and follow my instructions.
Okay.
Assume that the ship is at a point A. Now stand at a point from where you can see the boat at a perpendicular distance from the shore. Let that point be B.
Got it.
Now, walk any number of steps, say 10 steps, along the shore in a straight line.
Okay, Jill.
Place a stick at this point. Let this point be C. Now walk another 10 steps in the same direction. Stop here and place another stick and name the point D.
That's a lot of walking.
Now walk perpendicularly towards the land to a point from where you can see the boat through the stick at point C. Can you see the ship, Jack?
Yes, happily.
So place a stick here and name the point E.
So guys, what exactly was Jill trying to do? Any idea? No? Observe the triangle ABC and triangle EDC. Here, BC is equal to DC as they walk the same number of steps. Also, angle ABC is equal to angle EDC as they are right angles. Further, angle BCA and angle EDC are vertically opposite angles. This means they are equal, right? Therefore, the triangle ABC is congruent to triangle EDC by ASA criterion. Therefore, by CPCT, AB is equal to DE. So we can measure the distance between the points D and E, which is exactly the distance between the points A and B, or simply the distance of the boat from the shore. People used this method in older times when technology was not that effective. But remember, this method only works when the boat is steady. So you got to know how people actually applied ASA Congruence Rule in real life situation. The angle side angle congruence rule is actually a theorem. Now let's try and prove this theorem. The ASA Congruence Rule states that two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. To prove this theorem, consider the triangles ABC and XYZ such that angle ABC is equal to angle XYZ, angle ACB is equal to angle XZY, and BC is equal to YZ. We have to prove that these two triangles are congruent. Now consider the sides AB and XY. These sides can be related to each other in one of the three ways. AB is equal to XY, AB is greater than XY, or AB is less than XY. There is no other possibility, right? This means there are three cases. Now let us look at each case one by one. Now let us assume that AB is equal to XY. Also, it is given that angle B is equal to angle Y and BC is equal to YZ. So, by SAS rule, triangle ABC is congruent to triangle XYZ. If possible, let us assume that AB is greater than XY. So, there must be a point K on AB such that KB is equal to XY. Now observe the triangle KBC and triangle XYZ. KB is equal to XY by construction, and it is given that angle B is equal to angle Y and BC is equal to YZ. Thus, triangle KBC is congruent to triangle XYZ by SAS rule. Since the triangles are congruent, their corresponding parts will be equal. This means angle KCB is equal to angle XZY. But it is given that angle ACB is equal to angle XZY. This implies angle KCB is equal to angle ACB, which is possible only if the points K and A coincide, or simply when AB is equal to XY. Thus, by SAS rule, triangle ABC is congruent to triangle XYZ. Now for the last case, when AB is less than XY, we can choose a point M on XY such that MY is equal to AB. So, observe that in triangle ABC and triangle MYZ, AB is equal to MY by construction, and it is given that angle B is equal to angle Y and BC is equal to YZ. Thus, by SAS Congruence Rule, triangle ABC is congruent to triangle MYZ. Since the triangles are congruent, their corresponding sides will be equal. This means angle ACB is equal to angle MZY. But it is given that angle ACB is equal to angle XZY. This implies angle MZY is equal to angle XZY, which is possible only if the points M and X coincide, or simply when AB is equal to XY. Thus, by SAS rule, triangle ABC is congruent to triangle XYZ. So, in each of the cases, we concluded that triangle ABC is congruent to triangle XYZ, and thus angle side angle congruence rule is proved. We used SAS axiom to prove ASA Congruence Rule. Great! Now look at these two triangles. Can you say that triangle PQR is congruent to triangle KLM? Take your time and be back soon. So, you got the answer? If not, let's do it together. Look at the two triangles carefully. Here, two angles and one side of triangle PQR are equal to the corresponding angles and side of triangle KLM. But the side is not included between the angles. So, are the triangles still congruent? Yes, they are. Can you reason out why? Well, do you remember the angle sum property of triangles? I hope you do. It states that the sum of all the angles of a triangle is 180 degrees. This means angle P plus angle Q plus angle R is equal to 180 degrees. Now, on substituting the values, we get angle R is equal to 80 degrees. Similarly, angle K plus angle L plus angle M is equal to 180 degrees, which implies angle M is equal to 80 degrees. Now, in triangle PQR and KLM, angle Q is equal to angle L, QR is equal to LM, and angle R is equal to angle M. Thus, by angle side angle congruence rule, triangle PQR is congruent to triangle KLM. So we can conclude that without even finding the third angle, we can prove two triangles are congruent, because when any two angles are equal in two triangles, the third one will automatically be equal. This means two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. This is known as the angle side congruence rule. So guys, this is all for today. Now let's go through what we have done so far. The ASA Congruence Rule states that two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. The AAS Congruence Rule states that two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal.